At Chertsey in Surrey, on a wet morning in October 1971, Fighting Vehicles Research and Development Establishment engineers wheeled a squat aluminium hull onto the firing range and pointed a 76mm gun at a target 600 meters away. The vehicle weighed under 8 tons. The gun, adapted from the Saladin armoured car, had no business being mounted on something this small. When the breech closed and the round left the barrel, the hull rocked backwards on its horseman suspension. Dust lifted from the wet concrete, and the recoil energy dissipated through a carefully calculated system of hydro-pneumatic buffers. The vehicle did not tip, it did not shear its mounting bolts. It settled and the gunner cranked another round into the chamber. The vehicle was the FV101 Scorpion, and it was the answer to a Ministry of Defence requirement issued in 1967 for a combat vehicle reconnaissance, tracked, CVR-T, capable of being air-portable, amphibious with a flotation screen, and armed sufficiently to destroy Soviet reconnaissance vehicles on the North German plain before they radioed back what they had seen. The specification was written by the General Staff at the MOD's main building in Whitehall, cross-referenced against Joint Intelligence Committee assessments of Warsaw Pact reconnaissance doctrine, and handed to Alvis of Coventry. The problem set was cruel. British Army of the Rhine, BAOR, headquartered at Rheindalen, needed something that could keep pace with Chieftain main battle tanks across the Lüneburg Heath, cross the Weser without a bridge, be flown into a crisis inside a C-130 Hercules, and still carry a gun that could kill a BRDM-2 or a BMP-1 at combat range. The Americans had given up on the equivalent problem years earlier. The M551 Sheridan, which mounted a 152mm gun launcher on a light aluminium hull, was already earning a reputation for cracked mountings and misfiring rounds in Vietnam. Alvis's chief designer, William Bill Dunn, approached the weight problem from the opposite direction to the Americans. Rather than starting with the gun and building a hull around it, he began with the airframe constraint. A C-130 could carry roughly 19,500 kilograms in usable payload. The vehicle had to leave several tons of margin for fuel, crew and ammunition. That meant the hull could not exceed 8 tons combat loaded. Aluminium armour, specifically the 7017 alloy developed at the Royal Armament Research and Development Establishment at Fort Halstead in Kent, offered a weight saving of roughly 1/3 against equivalent steel for the same ballistic protection against 14.5mm rounds. The gun was the harder puzzle. The 76mm L23A1 fired a fixed round weighing just under 6 kilograms, generating recoil forces that ought to have thrown the Scorpion onto its back deck. Dunn's team solved it with a recoil system borrowed from artillery practice. A long-stroke hydraulic buffer and a recuperator that spread the impulse across nearly half a metre of travel, combined with a muzzle brake that vented propellant gases sideways. The mounting geometry placed the trunnions low in the turret, transferring load into the hull structure rather than the turret ring. When Warsaw Pact analysts at the GRU's Assessment Directorate in Moscow received their first clear photographs of the Scorpion, probably from the 1973 Royal Tournament display, though the exact provenance remains classified in the GRU archives. The response, according to later Soviet defector debriefs held by the SIS Soviet section at Sentry House, was straightforward disbelief. Their own equivalent, the PT-76, weighed 14 tons and mounted a comparable gun. The British had achieved the same firepower at just over half the weight. The question was how and whether the reported performance figures could possibly be genuine. The origins of the Scorpion lay not in tank design, but in the collapse of British imperial commitments east of Suez. Dennis Healey, Secretary of State for Defence in Harold Wilson's government, delivered the announcement to the House of Commons on January 16, 1968. British forces would withdraw from Malaysia, Singapore and the Persian Gulf by the end of 1971. The 1966 Defence White Paper had already killed the CVA-01 aircraft carrier program and the TSR-2 strike aircraft. What remained of the British military's global reach would have to be lighter, faster, and airlifted rather than sailed. For the General Staff, this meant rethinking reconnaissance from first principles. The existing scout car, the Ferret, was a Second World War concept updated in 1952, a small 4x4 wheeled vehicle armed with a Browning machine gun. Against the reconnaissance elements of a Soviet motor rifle division advancing across the inner German border, the Ferret would last minutes. The Saladin armoured car, its heavier cousin, could fight but could not swim, could not be dropped by parachute, and consumed too much fuel for expeditionary operations. The requirement that emerged from the Directorate of Land Service Ammunition and the Royal Armoured Corps in 1964 was for a family of vehicles sharing a common hull. The MOD designated it CVR-T for the tracked variants and CVR-W for wheeled. The tracked family would eventually comprise 7 vehicles: the Scorpion with its 76mm gun, the Scimitar with a 30mm Radan cannon, the Striker anti-tank missile carrier with swing fire, the Spartan personnel carrier, the Sultan command vehicle, the Samaritan ambulance, and the Samson recovery vehicle. All would share engine, transmission, running gear, and roughly 90% of hull components. The competition to build it went to Alvis of Coventry, which had produced the Saladin and Saracen. Alvis's team was small, under 30 engineers on the core design, but its head, Bill Dunn, had been thinking about lightweight armoured vehicles since the Second World War. He had worked on the Alvis Saracen in the 1950s and understood viscerally that every kilogram added at the concept stage would multiply through the design. The engine choice was decisive. Dunn selected the Jaguar J 604.2-litre petrol engine, the same power unit that drove the XJ6 saloon car. It was militarized, dry sump lubrication, uprated cooling, waterproofed ignition, and produced 190 brake horsepower from a package weighing 320 kilograms. The alternative, a purpose-designed military diesel, would have weighed nearly twice as much for equivalent output. The Jaguar unit gave the Scorpion a power-to-weight ratio of over 23 horsepower per ton, extraordinary for an armoured vehicle. On the test track at Chertsey, prototypes recorded a top speed of 82 kilometers per hour, faster than most contemporary main battle tanks could manage on a road, let alone across country. Petrol brought risks. A punctured fuel tank in a combat vehicle is a fire waiting for an ignition source. Dunn's team accepted the trade because the airlift requirement was absolute. Every alternative made the vehicle too heavy for a Hercules. The aluminium armour came from a parallel program at Fort Halstead, where metallurgists led by Dr. Peter Beeching had spent the mid-1960s testing weldable aluminium-zinc-magnesium alloys against small arms fire and shell fragments. The 7017 alloy that emerged offered protection equivalent to steel at roughly 70% of the weight, and could be welded without the cracking problems that had plagued earlier aluminium armours. The first Scorpion hull was laid down at Alvis's Holyhead Road factory in Coventry in 1969. The gun was chosen before the vehicle. In 1965, the Royal Armament Research and Development Establishment tested a range of weapons against captured Warsaw Pact reconnaissance vehicles at the Kirkcudbright Range in Dumfriesshire. The targets included a BTR-40, a BTR-152, and a PT-76 Hulk, recovered by unspecified means and shipped according to the still partial declassification in TNA file BAOR-194 through a Ministry of Defence sales organisation channel. The 76mm gun from the Saladin, firing a high-explosive squash-head round, defeated all 3 at ranges beyond 1,000 metres. The gun designation was L23A1. It was a low-pressure weapon, chamber pressures around 1,700 bars compared to over 4,000 bars for a Chieftain's 120mm gun, which was precisely what made mounting it on a light vehicle feasible. Lower pressure meant lower recoil. Lower recoil meant lighter mounting hardware. The trade was range and armor penetration. The L-23A1 could not defeat the frontal armor of a T-55 or T-62 main battle tank, and was not intended to. It was a reconnaissance killer, sized for the reconnaissance targets it would meet on the inner German border. The turret was a two-man affair, commander on the right, gunner on the left. Both had rotating cupolas with vision blocks giving 360-degree observation. The main sight was a Rank Precision Industries model L2A1 Unity Power periscope with an integrated 10 times monocular for engagement. Night observation came from an infrared searchlight mounted coaxially, an active system meaning it emitted infrared light and could be detected by any enemy with a suitable viewer, which the Soviets by the mid-1970s certainly had. Passive image intensification sights were retrofitted from the early 1980s. Ammunition stowage was 40 rounds, arranged in the turret bustle and forward hull racks. The gunner had ready access to 12 rounds. The remainder required the commander to hand them forward, a slow procedure under fire. The rounds themselves were fixed, projectile and cartridge case combined in a single unit, which sped loading but limited flexibility. 3 types were carried: HESH, high explosive squash head, for armoured targets, HE for soft targets and infantry, and smoke. The recoil mechanism was the design's central achievement. Bill Dunn's team, working with the Royal Ordnance Factory at Nottingham, developed a hydro-pneumatic system with a stroke length of 380 millimeters. When the gun fired, the barrel and breech recoiled against a piston, displacing hydraulic fluid through calibrated orifices. A nitrogen recuperator absorbed the final energy and returned the gun to battery. The whole cycle took roughly a third of a second. Peak recoil force at the trunnions was reduced from what would have been a hull-tipping impulse to something the 8-ton vehicle could absorb without lifting its front road wheels. The muzzle brake, a perforated cylinder screwed onto the barrel's end, vented roughly 30% of the propellant gas sideways and rearwards, reducing recoil energy transmitted to the mount by a similar proportion. The trade was a fierce blast signature. A Scorpion firing at night was visible for kilometers. Test firings at Kirkcudbright in 1971 demonstrated the system worked. A prototype hull, weighted to combat load, fired 100 rounds in a single afternoon without structural damage to the turret ring, hull mounting points, or suspension. The Master General of the Ordnance, General Sir John Gibbon, received the test report in November 1971 and approved production. Alvis received the initial order for 275 vehicles at a unit price, according to Hansard entries from 1973, of approximately £45,000. Cheap by armoured vehicle standards, roughly a third the cost of a Chieftain. Soviet analysis of the Scorpion began on the available evidence in 1973. GRU stations in London, Bonn and Vienna collected open-source material. Jane's Armour and Artillery entries, photographs from the British Army Equipment Exhibition at Aldershot, articles in Soldier magazine, and the RUSI Journal. The Technical Directorate at Kodinka in Moscow, which handled foreign armour assessment, produced its first internal paper on the CVR T family in late 1973. The paper referenced in the debriefing of Vladimir Rezun, later the writer Viktor Suvorov, who defected to SIS in Geneva in June 1978, expressed straightforward professional puzzlement. The Soviet assessment turned on 3 questions. How had British designers achieved the reported power-to-weight ratio without compromising armour protection? How was the 76mm gun's recoil managed on a hull of that mass? And what was the amphibious performance actually like? Could a vehicle that light genuinely swim across a river obstacle with a working gun? The armour question was the easiest to misread. Soviet armour design in the 1970s used steel plates of varying hardness, sometimes with ceramic inserts on newer designs. Aluminium armour was known. The American M113 personnel carrier used it. But the Soviets had assessed aluminium as inferior for combat vehicles, because of its lower resistance to shaped charge warheads and its tendency to burn under high explosive attack. The British choice to build a reconnaissance vehicle almost entirely of aluminium struck Moscow's assessors as either bold or foolish, and the initial assumption was foolish. Suvorov's debriefing, portions of which are held in the SIS files at TNA under KV series releases from the 2010s, indicated that GRU technical officers assumed the Scorpion must be more heavily armoured than photographs suggested, that there had to be spaced armour or applique plates hidden inside the hull. When a Scorpion was displayed at a NATO exercise in West Germany in 1974, with maintenance panels open and Soviet military attachés were permitted deliberately to photograph the interior, the assessment shifted. The vehicle really was that light. The armour really was that thin. The British had accepted vulnerability to almost any purpose-designed anti-armour weapon in exchange for strategic mobility. The gun mounting was the harder puzzle. Soviet designers had experimented with mounting large guns on light vehicles. The ASU-85 airborne assault gun, the PT-76 amphibious tank, and understood the recoil trade-offs. But mounting a 76mm gun on an 8-ton hull with reasonable accuracy retention across sustained firing was not obviously possible. The Technical Directorate initially suspected the L-23A1 was firing sub-caliber practice rounds during public demonstrations, not full-charge combat ammunition. This assumption survived until BAOR field exercises in 1976 and 1977, observed by Soviet military intelligence through liaison arrangements with the East German Ministry for State Security's HVA Directorate, showed Scorpions firing what were unmistakably full-charge HESH rounds at target ranges. At Sentry House on Westminster Bridge Road, SIS's Soviet section catalogued what they knew of Soviet interest in the CVR-T program. The picture pieced together from Rezin's debriefing and from Intercept product, distributed through GCHQ's K Division at Cheltenham, was that Moscow rated the Scorpion as an asymmetric solution to a problem Soviet doctrine did not fully recognize: how to reconnoiter against an enemy who had strategic depth and airlift, rather than the fixed frontage of the Central European theatre. The Joint Intelligence Committee, chaired in 1977 by Sir Anthony Duff, took a distinct interest. If Moscow was baffled, Britain had achieved technological surprise. The JYC Minute of March 8, 1978, recommended that Scorpion export policy be reviewed to maintain that advantage for as long as possible. Export sales began almost immediately. Alvis sold Scorpions to Belgium, Iran under the Shah, Nigeria, Oman, Thailand, and, in a decision that would matter within a decade, to Argentina. The Iranian order, signed in 1974, was for 250 vehicles at a total contract value of roughly £45 million, negotiated through the Defence Export Services Organisation at the MOD. When Reza Shah Pahlavi fell in February 1979, the outstanding balance of the order fell into a diplomatic and financial limbo that persisted through the 1980s. The Argentine sale is where the design's export success collided with its combat debut. In 1978 and 1979, Argentina purchased CVR-T variants, Scorpions and Scimitars, through a contract negotiated by Alvis with the approval of the Callaghan government's Foreign and Commonwealth Office. The sales were consistent with British defence export policy of the period, which treated Argentina as a stable South American partner with no obvious hostile intent toward British interests. The vehicles were delivered to the Argentine Marines' 1st Marine Amphibious Vehicles Battalion at Baterias near Bahia Blanca. On April 2, 1982, 12 Argentine Scorpions and Scimitars, along with LVT-P7 amphibious tractors, landed at York Bay outside Stanley in the Falkland Islands. The vehicles that Alvis had designed to reconnoiter for BAOR on the North German plain were now being used against a token British garrison of Royal Marines from Naval Party 8901. The Argentine Scorpions were the same vehicles the British Army was operating. The Blues and Royals, a squadron of the Household Cavalry, equipped with the 4th Field Squadron's Scorpions and Scimitars, deployed from the United Kingdom as part of the task force under Rear Admiral Sandy Woodward. The 2 Blues and Royals troops, commanded by Captain Roger Field and Lieutenant Lord Robin Innes Kerr, took 8 CVRTS south aboard MV Elk and the LSL Sir Lancelot. The Royal Marines' assessment before landing was that the CVRTS were essential, the only vehicles light enough to be landed across a beach and mobile enough to keep up with the infantry, but with a real gun. The professional judgment at the MOD was that the ground of East Falkland, soft peat, boggy, cross-hatched with stone runs, would defeat any tracked vehicle. This judgment proved partly wrong. The CVRTS had ground pressures of roughly 0.36 kilograms per square centimetre, lower than a man on foot in most conditions. Where infantry sank to their knees in peat bog, the Scorpions and Scimitars floated across on their wide tracks. The Blues and Royals fought from San Carlos up through Teal Inlet and onto the Stanley approaches. At Mount Longdon and Wireless Ridge, the Scimitar's 30mm Radon cannon suppressed Argentine positions. The Scorpion's 76mm gun engaged bunkers and Argentine armoured vehicles at long ranges. The British CVRTS destroyed several Argentine Panhard AML-90 armoured cars in the closing days of the campaign. The Argentine Scorpions were captured intact or lightly damaged on the outskirts of Stanley on June 14, 1982. Some were shipped back to the United Kingdom for technical examination at the Fighting Vehicles Research and Development Establishment. The Blues and Royals had lost none of their vehicles to enemy fire, though several had to be recovered from bog. The design had done in the South Atlantic precisely what it had been designed to do 12,000 kilometers away in Germany. The Soviet assessment of the Falklands Campaign when it came in early 1983 through GRU channels was that the CVRT had demonstrated capabilities that Moscow's technical directorate had continued to doubt. Inside BAOR, the Scorpion's operational role was reconnaissance in force. The 1st British Corps, based at Bielefeld and comprising 4 armoured divisions in the 1970s and 1980s, held the northern shoulder of NATO's Central Army Group frontage. Reconnaissance regiments, the 15th/19th, the King's Royal Hussars, the 16th/5th, the Queen's Royal Lancers, and others rotating through, operated CVRTs as the eyes of the Corps, screening forward of the chieftain-equipped armoured regiments. The tactical doctrine, laid down in Army Field Manual Volume 2, Part 1, was that reconnaissance troops would find the leading elements of a Soviet Third Shock Army advance, identify unit strengths and axes, and either withdraw under fire or, if the target justified it, engage. The 76mm gun on the Scorpion existed for the second case, to kill Soviet reconnaissance vehicles, BRDM-2s, BMPs, MTLBs, before they could report British positions back to their divisional headquarters. The exercises across the North German plain were relentless. Exercise Lionheart in September 1984, the largest British military exercise since the Second World War, deployed 131,000 troops across Lower Saxony. Scorpions and Scimitars of the reconnaissance regiments operated forward of the main battle lines for a fortnight. In the rain, across ploughed fields and through pine forests, refuelling from 4-ton Bedfords, and eating compo rations in their turrets. The vehicle's small size, under 2 meters tall, under 2.2 meters wide, let it hide in ditches and behind hedgerows that a chieftain would tower over. Crew life was cramped. 3 men, commander, gunner, driver, inside 8 tons of aluminium with a 4.2-litre petrol engine 2 feet behind their heads, generating cabin temperatures in summer that reached 40 degrees. The driver sat forward and left with a single hatch above his head. Sleeping in the vehicle meant sleeping upright or on the engine deck outside. Corporal Ken Lukowiak of the Parachute Regiment, though writing later about the Falklands rather than Germany, captured a general truth about CVRT crew life. The vehicles were reliable, quick, and profoundly uncomfortable. The Jaguar J60 engine required constant attention. It was petrol, it had complex ignition, and its cooling system depended on a fan drive that could shed its belt without warning. REME light aid detachments at squadron level carried spare engines that could be swapped in under an hour by a fitter team. The engine's civilian origins, the same block that drove Jaguar XJ6s down British motorways, meant that spares were commercially available in a way that purpose military engines were not, which suited both Alvis's export customers and the Treasury. GCHQ's monitoring of Warsaw Pact communications through the 1980s indicated persistent Soviet uncertainty about how the CVR-T family would perform in a general war. The Intercept product, released in redacted form in the 2010s under the Public Records Act, showed Soviet planners assuming that the vehicles were more vulnerable than the British claimed, but faster and more numerous than a straight order of battle count suggested. Soviet reconnaissance units on the East German side of the inner German border were briefed to identify Scorpions as high-priority targets. Kill the eyes before the fists arrive. The Central Intelligence Agency, through liaison with SIS, occasionally requested British assessments of the CVR-T family's export performance. The Reagan administration's Defense Department examined the CVR-T as a possible model for the American M113 replacement in the mid-1980s. The Bradley fighting vehicle, which was chosen instead, ended up weighing over 20 tons. The Ministry of Defense issued in 1987 its first serious study of a Scorpion replacement. That study became, over the following decade, the Future Family of Light Armored Vehicles program, which produced nothing that reached service before the Cold War ended. The Scorpion continued. Between 1971 and the end of production in 1994, Alvis built roughly 3,000 CVR-T hulls across all variants. The Scorpion itself, the 76mm gunned original, was produced in fewer numbers than the Scimitar, which the British Army preferred for close reconnaissance because its 30mm Radan cannon could fire on the move and engage lightly armoured targets more quickly. By the late 1980s, most British Scorpions were being converted to the FV101 Scimitar standard, or held in war reserve. The 76mm gun's utility declined as Soviet armour improved. A Scorpion round could not defeat the frontal armour of a T-72, which by 1980 was the standard main battle tank of the group of Soviet forces Germany. The design's genius was that its limitations did not matter for its actual mission. A Scorpion was never meant to fight a T-72. It was meant to find one, report on it, and either evade or destroy the reconnaissance vehicle screening it. Against a BRDM-2 or a BMP-1, the 76mm HESH round was decisive. Against a T-72, the Scorpion crew's job was to radio back position, strength and direction of advance, then move. Ministry of Defense procurement through the 1980s under Michael Heseltine and George Younger as successive defense secretaries treated the CVR-T family as a proven system that did not need immediate replacement. The Knott Review of 1981, which cut the Royal Navy's surface fleet, and would have withdrawn HMS Endurance from the South Atlantic, left the Army's armoured reconnaissance capability largely untouched. When the options for change review followed the Berlin Wall's collapse in November 1989, the CVR-T survived that too on grounds that had shifted from Central European deterrence to global expeditionary utility. By the time the Soviet Union dissolved in December 1991, the Scorpion had served for 20 years without a peer competitor in its weight class. The Americans had abandoned the Sheridan in 1996 without a direct replacement. The French AMX-10RC was heavier and wheeled. The German Lutz was heavier and wheeled. The Soviets themselves had continued with the PT-76 and, from the late 1970s, the BMD family. But the BMD was an infantry fighting vehicle for airborne troops, not a reconnaissance vehicle in the CVR-T sense. What the Soviets never fully replicated on the available evidence from post-Cold War access to Warsaw Pact Design Bureau was the specific combination Bill Dunn's team had achieved. A genuine 76mm gun, aluminium armor-proof against small arms and shell fragments, an amphibious hull, air portability inside a C-130, a top speed above 80 km per hour, and a crew of 3. Every Soviet approximation had sacrificed one or more of those parameters. The PT-76 was heavier and slower. The BMD-1 was lighter but less well armed and not intended for core reconnaissance. The Joint Intelligence Committee's 1978 assessment that Britain had achieved technological surprise proved correct for the entire remainder of the Cold War. The surprise did not translate into decisive military advantage. The Cold War was decided by nuclear balance, economic exhaustion, and political change. Not by reconnaissance vehicles, but it did earn foreign exchange, sustain Alvis and its supply chain in the West Midlands, and give BAOR a reconnaissance capability that the Soviet General Staff never quite worked out how to counter. Bill Dunn retired from Alvis in the late 1970s. He died in 1994, the year the last CVR-T rolled off the Coventry production line. Alvis was absorbed into GKN Defence in 1998 and then into BAE Systems in 2004. The Holyhead Road factory in Coventry, where the first Scorpion hull was welded together in 1969, was demolished. The site is now retail and housing. The vehicles themselves outlasted the Soviet Union that had puzzled over them. Belgian Scorpions served in NATO's Kosovo force in 1999. British Scimitars, direct descendants of the Scorpion, sharing 90% of the same components, served in Iraq from 2003 and in Afghanistan through the 2000s and 2010s. The Household Cavalry Regiment, which had taken Scorpions south to the Falklands in 1982, was still operating CVR-TS in Helmand Province 30 years later. The Jaguar J60 petrol engine had by then been replaced with a Cummins diesel in the upgraded variants, and the aluminium armour had been supplemented with add-on kits against roadside bombs. But the basic hull, Dunn's 1969 design, remained in service until formal withdrawal in 2023. The Soviet Technical Directorate at Kodinka closed with the rest of the Soviet defense apparatus in 1991. Its files on the CVR-T family, so far as they can be reconstructed from the fragmentary Russian archival releases of the 1990s, and the memoirs of former GRU officers, contained a professional judgment that the British had achieved what should not have been achievable: full firepower on a chassis half the expected weight, and had done so with a design team of 30 engineers in a Coventry factory that also built lorries. The National Archives at Kew hold the surviving Ministry of Defence files on the CVR-T programme in the WO32 and DEFE 24 series, released in phases through the 2010s. The Imperial War Museum holds a Scorpion in its Land Warfare Hall at Duxford, alongside a scimitar recovered from Bosnia in the late 1990s. The Tank Museum at Bovington in Dorset holds 3 CVR-T variants, one of them a Falklands veteran with battle damage from the East Falkland Campaign still visible on its glacis plate. What the Scorpion represents in the longer arc of British defence policy, from Attlee's austerity through Thatcher's rearmament, is the discipline forced on a country that had run out of empire and had to fight, if it fought at all, on the terms available. The CVA-01 aircraft carrier was cancelled. The TSR-2 was cancelled. The V-bomber force was retired by 1969. What survived in the armoured vehicle world at least was the Chieftain, heavy, slow, expensive, and the Scorpion, light, quick, cheap, and unexpectedly effective at the job it had been designed for. The Soviet analysts who could not quite believe the Scorpion's specifications were reading the vehicle correctly. They were reading it as an artifact of a country doing more with less, and doing it well enough to make Moscow's technical directorate write and rewrite its assessments for 20 years. Bill Dunn's 8-ton hull with the 76mm gun outlasted the state that had puzzled over it. It was still being driven by household cavalry troopers on operations, in a decade the Soviet Union did not live to see.